Good morning, students. In previous session, we have discussed about some logic and fact. We have discussed about logics. What is logic, first of all? How it used in AI. Then how we can formalize a logic by from the sentences like that, right? So we have also discussed propositions. Now, proposition is nothing but a sentence, or we can say statement, or a simple declarative sentence, right? Okay. We have discussed about the propositional logic types like syntax, semantic. After that, we have discussed about syntax, atomic, and complex sentences. Right. So these are the type of sentences in which propositional logic may follow. Right. Okay. We have discussed these points already. We have discussed some of the logics that that will showcase the idea and definition of it. We have also seen some symbols that is used in propositional logic, right? In the previous session only. Okay, we have discussed about this and negations, then disjunctions, conjunctions, that is and or operations. These are the various operations that we are going to use while using the propositional logic, right? Now, today we are going to start with another topic that is the name of the topic is representation of simple facts in logic, right? So first of all, if we want to represent this as an fact, we need to know what is facts and logic, right? So we have already discussed this logic and things regarding this in the previous session, right? So representation of simple facts in FOPL, right? So now, this representation needs models or world in terms of object, right? So this will represent real world facts and things in a logical proposition that is written as well formed formulas in propositional logic, right? So ultimately, what it will do, it will take things, or it will termed real world thing into the object. It will show like that, and it will apply some logics on that, right? So it will for this we have also discussed that to represent such things we need to use some symbols for that, right? So basically here symbols used for representing the logics or representing the objects, right? Okay, representing so here representing the objects, then representing its properties, and representing its relation, right? So this will show the symbol will show these things, right? First of all, क्या चीज है, उसकी क्या क्या प्रॉपर्टीज हैं, ठीक है? और उसके बाद होता है उसका क्या रिलेशंस है, right? Okay, so basically it will represent objects, property, and relation between those objects. So symbol here used are form of the following things, like the sentence what we are using and how it represent, right? So we have some of the facts that we need to know while using the symbols to form proper or to form well in into the formulas, right? So first of all, first point is to set off all uppercase English alphabets, because we can represent this as an uppercase, the sentence or the word written in the uppercase only, right? So this one is the first formula or form. Secondly, we can represent it with a set of digits, right, from 0 to 9. We can use such digits to show, to represent, or to make some logic from the sentence by using this symbol. Right? Third one, underscore the character. That means, suppose if here one sentence is there, that is all dogs are brown, right? So this can be written in propositional logic, right? As we have already discussed in the previous session, that we need to use conjunctions, disjunctions, then negations, like that, right? So we for third thing, we need to represent it as an underscore character, and it will use first order prediction, right? So here whole term or whole things, that is simple representation fact, is ultimately what FOPL, right? Right, using in FOPL, that means it is called as an first order predicate logic, right? That directly that doesn't show direct sentence here, or the direct meaning of the sentence, but ultimately shows the formula that is behind the sentence, right? So this is the representation of simple fact in FOPL. Now, taking example of defining a sentence first of all. So every atomic sentence is a sentence, right? Now we know that what is atomic sentence. Fine. Here it is defined as a predicate constant, right? Suppose we are defining it as an small n, right, followed by t1, t2, tn terms, that is enclosed with the parenthesis or separated by, right? It can be separated by the commas, or it may use the parenthesis for this, right? So suppose if you're taking example, as we have taken seven example of it, how we can write the sentence, or how we can define the sentence by using the facts or logics, right? So first of all, if s is a sentence, right, if suppose if s is a sentence, then we can write it as a negotiation of this s is also a sentence. Fine. Secondly, if s1 and s2 are sentence, right? So we can write it in a conjunction way. We need to use and operator here. So s1 and s2 are both of these are sentences. Fine. This is the second way. Third, disjunction, that means if S1 and S2 are sentence, the possibility is it may not, or it S1, or we can also call it S1 or S2 are sentences, right? So this one is also possible. Fourth, implies. If S1 and S2 are sentence, then S1 implies to S2. This is the sign of implication, right? So we can also write it in an implication way. Next, equivalence. If S is equal to S2, then we can write it as an equivalence sign. S1 is equivalence to, right? Sixth is, if taking value of x, if x is a variable and s is a sentence, then for every x of s is a sentence, right? Suppose जहाँ पे भी x का use होगा वो variable होगा, and that is used in a s, right? So for every x, जहाँ पे भी s use होगा, x use होगा, that is considered as a sentence for, right? So basically this is this one is a 6 point. Coming to the seventh one, now if the x is variable and s is a sentence, then for every not for every, but existence, s is a sentence, right? um, okay, now here the for every and essentials, right? This is called essential sign, right? Either x may be or may not be sentence, right? For here, for every x, s is a sentence, that means जहाँ पे भी x होगा, x is in s sentence, right? Because it's using universal fact, right? For every, for all x such that, that this symbol is used for the universal variable, right? Whereas essentials use this symbol. And now essentials means for some x, such that, right? Not for every, for some x, right? So these are the quantifiers that are used for this calculation or for making this sentence, right? So here essential is for every, for not every, but for essentially x, s is a sentence. Now coming to the quantifiers of it. Now there are generally two main quantifiers used in a first order predicate calculus, that is FOPL. So first is, as I have already told, that first is universal and next is essential, right? So for every x, that will use the implies sign. This is called the implies sign. That means for all x such that, it shows that in each and every sentence or each and every whenever x is used, it follow in the same sentence, right? So this shows the constraints. It will shows the constraints of sentence that containing a variable, right? Secondly, quantifier is followed by the variable and a sentence, right? It may be followed by a variable and then a sentence. So suppose taking example of suppose taking example of one sentence, that is first one, all boys like football, right? So for every boy, right, we can write it, all boys like football. That means all here universal for every x, that means boys like football, that is 10 to football x comma, right? We can formula, or we can make logical formula by on the basis of this sentence, right? This both shows the same meaning. That means if I want to write this sentence in a logical way, I can write it like this. So for every x, because here at the term the word uses all, that means for every, right? So for every x, right? Now x is what? Boy, right? X is boy, right? Like football. That means we can write tense, right? Implies sign here, we can write like that, right? Implies like football, that is x comma football. So this one is for the universal, and secondly for essential, it will use some of the, right? Not everyone, but some of the boys, right? So some boys like football. So essentials boys, and we are going to use and symbol, as we have used here implies symbol for essential. We are going to write and symbol for essential, right? So for every x and will like football, right? So the meaning of this sentence is, maybe some boy may like football or some not, right? So for this particular word, we are going to write this action, right? So this is the simple representation of facts that has been used in the logic. Now here, this representation is shown in your book. That is the now first point for this is, it will use the proportional logic, because it is simple to deal with, and a decision procedure for it exists, right? So it is used in the in simple way, or it is used to deal with a simple way, and to make a decision procedure for it, right? Now in order to draw a conclusion for this, so we have taken example of this, like here there are some more example. Marcus is a man, that is for every x, that what we have seen in the previous slide, that is men and Marcus, right? So every men, Marcus is a man, right? So for every x, it's men, so Marcus is also men. With Plato is a man, that is defined here. Plato. All men are mortal, right? That doesn't mean it shows all men are mortal. That is universal. It is not talking. They are not talking about the Marcus or Plato, right? If we want to write about the single one, then we can write it as a Marcus is a martyr. Marcus is mortal, right? But it's written all men are mortal, right? So it's written in a general manner, right? So mortal, and for every x it's mortal, right? So here x is men, right? So for every men are mortal, right? So it goes like that. Now, here the proposition logic failed to capture the relationship between any individual being, a man, and that individual being a mortal. It's here propositional logic that what we have used here. It's comparatively failed to capture the relationship between those object or those individual beings. Now, this how this sentence can be represented so that we can infer the third sentence from the first two, right? So we can, okay, propositional logic comments only the existence of a fact that may or may not be cause in the may not be in the case of the world being represented. Right? It has a simple syntax and simple semantic. It suffices the illustrator of the process of interference, and propositional logic quickly becomes impractical even for very small, right? So by to represent two different sentences, we are going to write third one, right? So it will work like this only. Here, this predicate logic use first order FOPL model, right? That shows the world in terms of object, that is, which are things with individual identities, that each and every objects that are in the real world can be represented as an object, right? Having its own identity. Suppose if we are talking about um, uh, two um, individual, right? Suppose one is faculty and one is student, right? So for faculty it's having its own ID card, and for student it's having its own student ID card, right? So each one having its own identity and then role for that, right? So in first order predicate logic will identify or may, make or consider as an use symbol for the objects too, right? Secondly, property of an object that distinguishes them from other objects. With properties, that is ultimately what we have seen here, the identities and the its property. Third one, it will talk about the relationship or relation that hold among a set of objects. Fourth, it will also see the functions that are the subset of relation, where there are only value for any given. So these are the things that we have already discussed in the previous two slides, but here are some different sentence that has been written for better understanding. Okay, that's all for the day. If you have any doubt or query regarding this, just let me know. Uh, and yes, make sure that you have seen the previous video, right? If you haven't seen yet, first of all go through that first part of the video, and then come to this one, right? So you'll get the better understanding for this topic, right? uh, that's all. Thank you so much.